Hello friends, welcome back to our channel Smart Techie. Today we shall be dealing with another module which deals with flow of water through soils. Flow of water through soils is nothing but permeability of the water. So what is actually permeability? It is defined as the property of the porous materials which permits the seepage of passage of water through interconnecting voids. Now, in the first module, we have already studied the soil structure, and we know that soil is usually made out of solid particles, and in between, it is usually having the gaps, which are also known as voids. So all the soils which are having continuous voids are usually called as the permeable soils, for example, gravels. Okay, let's check out this particular figure over here. We have the soil particles, and then we see that the gaps in between or the voids in between are basically more. They are continuous. That's why it becomes a porous material as well as a permeable material. Whereas the soils which are having less voids are usually called as impermeable materials, for example, stiff clay. Now let's take the example shown over here. We have the soil particles and there are also gaps in between, but they are not continuous in nature, or basically they are less. So such type of materials are porous, but they are called as non-permeable material. And here we find that the soil particles are densely packed and voids are basically less. Hence, it becomes non-porous and non-permeable material. Now, why is permeability important for us? Permeability, or the study of seepage of water through the soils, is important with respect to many of the engineering problems. For example, it helps to determine the rate of settlement of a saturated compressible soil layer. We can calculate the seepage which is happening through the body of earthen dams. We can also check out the stability of slopes. We can find out the uplift pressure under hydraulic structure and also safety against piping. The groundwater flow of the wells and drainage of the soils can also be calculated if we are aware about permeability of soils. So it was first Darcy who studied permeability of soils, and depending upon which he stated something which is called as Darcy's law. It states that the rate of flow or discharge per unit time is proportional to the hydraulic gradient I. Q is proportional to I into A. Okay. So suppose if I want to remove this proportionality sign, then what I have to do is I have to insert a constant K over here. So his law states that Q is proportional to I into A, which becomes Q is equal to KIA. Now Q is nothing but the discharge which is happening per unit time. A is nothing but the cross-sectional area. I is nothing but the hydraulic gradient. We have to remember one more thing, that this law is valid only for the laminar flow conditions. It is not applied to the turbulent flow. Now we have inserted this constant K. This constant K is nothing but coefficient of permeability. Now let us assume that we have a soil sample which is as shown over here. It is having the cross-sectional area A and the length of the sample is given by L. So we have the inflow of the water, that is H1 is nothing but the initial head and H2 is nothing but the final head. Now what is I? Hydraulic gradient I is nothing but change in the heads divided by length of the sample. So instead of writing Q is equal to KIA, I can also write it as Q is equal to K H1 minus H2 divided by L into A. Because what is I? I is nothing but H1 minus H2 divided by L. Change in the heads divided by length of the sample. Now, let us also see what are the factors affecting the permeability of the soil. So, initially we have the size of the particles. We all know that soil is divided into coarse grained soils and fine grained soils. So, coarse grained soils have permeability more, fine grained soils have permeability less. So, I can write it as K is proportional to D square. As the diameter increases, permeability increases. Next, we have specific surface area and the shape of the particles. This we can say that it is inversely proportional to the permeability. Higher the specific surface, lower is the permeability. So it is inversely proportional. Coming to the shape, the rounded particles have more permeability. The angular particles basically have less permeability. This is again related to specific surface because specific surface of angular particles is more when compared to the rounded particles. Therefore, rounded particles have more permeability, angular particles have less permeability. Then we have something which is called as the properties of the pore fluid. Properties of the pore fluid is nothing but the water properties, okay, which is nothing but unit weight, viscosity, etc. As in, unit weight will not affect much, but when it comes to the viscosity, as the viscosity increases, permeability decreases. Then we have something which is called as the voids ratio. So, as the voids ratio is more, permeability is more. As the voids ratio is less, permeability is also less. Then we have something which is called as structural arrangement of the soil particles, which is nothing but the soil structure. So, it all depends upon how much is the soil compacted. Suppose if it is having flocculated structure, that is a random orientation, then we can say that the permeability is more. But suppose if it is having the dispersed structure, then the permeability is usually less. Then there is something which is called as the entrapped air and the organic impurities. So, of course, if the voids are filled with the air or if they are filled with the organic impurities, how will the water flow out? So, the permeability is less. Whereas, if the voids are free from entrapped air and organic impurities, the permeability will be more. And lastly, we have something which is called as the absorbed water. So, absorbed water is nothing but the water layer which is formed around the soil particles, and it is more whenever we talk about the fine grained soils. Okay, so absorbed water reduces the size of the voids and therefore the permeability also decreases. So, all these factors play a very important role and they affect the permeability of soil. I repeat, it depends upon size of particles, which is directly proportional. It depends upon specific surface, which is inversely proportional. Shape, rounded is more, angular is less. Properties of pore fluid is nothing but viscosity, which is again inversely proportional. Voids ratio is directly proportional. Voids are more, permeability is more. Structural arrangement for flocculated it is more, for dispersed it is less. Entrapped air and organic impurities it is again, if the entrapped air and organic impurities are more, permeability is less. So it is inversely proportional. When it comes to absorbed water, it is nothing but the water which is surrounding the soil particles. So if absorbed water is more, permeability is less. So it is again inversely proportional. Thank you.